Chemistry students, this is going to be a video on drawing covalent compounds. So first, remember ionic versus covalent. Ionic compounds have a metal, so an element left of the stair step. Covalent, both elements will be right at the stair step, or hydrogen. Both elements right at the stair step, non-metals or hydrogen. If you think about it, at the beginning of the year, a while back, we would draw, let's say we were drawing like calcium chloride. So if I said draw that, you look up calcium's valence electrons, which calcium has 2. So this is an ionic compound. This is ionic. It's got a metal in it. Got a metal which wants to lose electrons. This calcium wants to lose 2 electrons. Chlorine's a non-metal. Chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So chlorine wants to gain 1. So calcium can give 1 electron. Remember, there's 2 electrons in a bond. 2 in a bond. 2 electrons in a bond. So chlorine, everything right at the stair step. This is your one rule. Everything right at the stair step wants to get 8 electrons. Everything right at the stair step is trying to gain electrons, get to 8. Actually, everything from the nitrogen family over is trying to gain and get to 8. So chlorine has got to get to 8. Calcium has 1 more to get rid of. Put another chlorine in. Can give to there. Okay, those are ionic compounds. So metal, non-metal. The metal is getting rid of electrons. Non-metal is gaining electrons. These compounds that we're going to draw now are covalent compounds, meaning 2 non-metals. So all the elements are trying to get to 8, unless you have a hydrogen. So like on this, both elements are trying to get to 8 valence electrons. They're trying to share electrons to get to 8. Both elements trying to get to 8. If you have a hydrogen, it's a little different. Quickly here's the rule. So these are called Lewis structures, or the structural formula. First thing, figure out the location of certain elements. Hydrogen's always on the end. Hydrogen always only forms 1 bond. Hydrogen always only forms 1 bond. I'm going to skip a couple things. Carbon always forms 4 bonds except for 1 time. Carbon monoxide, it does not. Okay, it does not. I don't think I need to read through the rules for that. I'll just explain how you draw some of these. So in terms of drawing these, it's going to be a little different. You want to do it this way. I'm going to start with a little tougher one. So on your sheet here, I'm going to start with SO2, which would be a pretty tough one. I'm going to start with SO2. I'm going to draw that. So here's what you want to do. Count your valence electrons. So find sulfur in the periodic table. It's got 6 valence electrons. Remember, just go to the family at the top. Oxygen also has 6, but there are 2 of them. So that would be 12. So 6 valence electrons, sulfur, 12 from the 2 oxygens. Add them up. That's 18 total. So you have 18 electrons you can use. You can't use 20. You can't use 15. You got to use 18. Bonds count as 2 electrons. Okay, bonds count as 2 electrons. So here's how I go about this. First element's almost always your central element. That's your central element there. Okay, this is your central element here. Here's your central element. So put in sulfur. I'm going to give single bonds. There's 2 oxygens. So I'm going to go single bond to oxygen, single bond to oxygen. That means we've used 2 electrons there and 2 electrons there. We've used 4 electrons total at this point in time. I'm going to give everything there 8. All of these want to get to 8 unless you have a hydrogen. So this wants to get to 8. It's got 2 right there. So 2, 4, 6. Those are called lone pairs of electrons. These are called shared pairs in the bond. Remember, there's 2 electrons in the bond. They're called shared pairs of electrons. So lone pair, lone pair, lone pair, shared pair. So it's got 8 around it. Lone pair, lone pair, lone pair of electrons in a shared pair. So it's got 8 around it. And sulfur's got a shared pair and a shared pair for 4 electrons. It needs lone pair to get to 8. So everything's got 8. We might be done. If we've used 18 electrons, we're done. So remember, that's 2, 4, 6. Bond counts as 2, so that's 8, 10, 12, 14, 16, 18, 20. We've used too many. You have to use 18. So if you ever use too many, make a double bond. Make more sharing. Okay, so if I put a double bond, doesn't matter which side you put on. If I put a double bond there, now oxygen has 10 electrons around it, so I got to erase a pair. And sulfur now has 2, 4, 6, 8, 10 around it, so I have to erase a pair off of it. So you should have, in this one, you have a double bond and a single bond. Again, this should have 8 around it. Lone pair, shared pair for 8 electrons. lone pair, shared pair of electrons, shared pair of electrons, shared pair of electrons for 8, and 2, 4, 6, 8 around that. Let me pick out a couple others to do here. Let's say if you're doing like hydrogens only form one bond. Hydrogens have one valence electron. They never form more than one bond. They never have lone pairs on them. Listen to me again. Hydrogens only have one bond, no lone pairs. So hydrogens are in a lot of these. Hydrogen's got one valence electron. Chlorine's got 7. We have 8 to use. So we go hydrogen connected to chlorine. We've used 2 electrons. Used 2 of them. So lone pair on chlorine, lone pair on chlorine, lone pair on chlorine to get it to 8. Hydrogen never has lone pairs on it. It only has one valence electron. It just wants to have 2. Its first energy level only holds 2 electrons, so it just wants to have 2. Sorry, moving that around. So 2, 4, 6, 8. Chlorine's got its 8. Hydrogen's good. We're good right there. Eventually, we'll worry about the molecular geometry, the shape of these molecules. You have to tell me what shape that is. So at some point, you'll do that. Let me do maybe 2 more. 2 more. Let's say we have, we'll do this one. Nitrogen's got 5 valence electrons. Hydrogen has 1, but there's 3 of them, so that'd be 3. Again, we have 8 to use. Electrons, so we got to use exactly 8, and bonds count as 2. So if we go nitrogen is your central element, we go hydrogen, there's 2 electrons. Hydrogen, there's 2 electrons, and hydrogen, there's 2 electrons. The hydrogens are good. They always just want to have a bond coming off them. So 2, 4, 6, lone pair of nitrogen gives it its 8. There's your 8 from there. All right, we'll do, I would tell you on L, carbon is your central element. Carbon's your central element. Everything comes off of carbon. Okay, carbon's your central. Everything comes off of that. This is a chain. I'm not too concerned about that at that point in time, but those are chains of elements. Carbon is your central right here too. So carbon's your central element on this one. Everything comes off of that. Carbon's your central there. Let me do one more. I'll do letter J. Letter J. So carbon's got 4 valence electrons. Chlorine's got 7 times 4 is 28. So we have 32 electrons to use. 32 electrons to use total. Central element is carbon. 4 chlorines coming off. So we got chlorine, 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 chlorine. Give them all single bonds. I would tell you your chlorine is done. It's got 2, 4, 6, 8 electrons around it. Each chlorine wants to get to 8. So lone pair, lone pair, lone pair. So it's got 6 unshared and a shared pair of electrons. Same thing with that one. And if you count those up, there's 8 around each of these. So that should be 32 electrons we've used from there. So try to draw what you can on this front page, and we'll work through those.